Hi there. We're going to be doing some chain rule problems today. I've got 5 here. If you don't see the type of chain rule problem that you're looking for, maybe try another one of my videos. This is my first one, but I will be posting many more, hopefully. These chain rule problems are based on the use of the power rule because these are all involving an exponent. Okay. And if you don't remember the power rule, maybe go and review that before you watch the rest of this video. Okay, I'm going to quickly go through the mechanics of how to solve these problems. It's all pretty straightforward, and I think you'll see the pattern once we do it a couple times. Okay, so with the power rule, remember what we do is we bring down the power in front and reduce it by 1. Okay, so for example, if I'm differentiating x cubed, right, I bring the 3 down front, rewrite the x, and then reduce the power that the x is to by 1. So it becomes 3x squared. All right, we're doing a very similar thing here, except we have to do the additional chain rule element of multiplying by the derivative of the inside, okay, inside of the function. All right, so what do? We bring down the 2 of the exponent. This is for number 1. Okay, we bring down the 2 of the exponent. Okay, we rewrite what's inside the parentheses. We reduce the exponent by 1. 2 minus 1 is 1. Okay, then we multiply by the derivative of what's inside here. The derivative of x squared plus 1 is 2x. So we multiply by 2x. Okay, now that's not quite the final answer because we need to simplify. And so what we're going to do is we're going to multiply these 2 terms because they can be consolidated. 2 times 2 is 4. So this can be rewritten as 4x x squared plus 1. And we can drop this 1 as this 1 exponent here because anything to the first power stays the same. Okay, so then this is your final answer. All right, so then number 2, same deal. We bring the power down in front. So the 3 comes down here. We rewrite the inside. We drop the 3 by 1 to 2. We multiply by the derivative of the inside, which in this case is 2. Okay, because the derivative of 2x is 2. And then we consolidate by doing 3 times 2, which is 6. So our final answer is 6, 2x plus 1 squared. All right, are you guys getting the pattern? Let's see if you can do this next one by yourself maybe, and then follow along with me and see if you're right. Okay, so we're going to start with the exponent, take the 2, put it in front, rewrite the inside exactly as it is. Drop the power by 1, multiply by the derivative of the inside. Okay, derivative of this is going to be 6x minus 2. All right, so then our final answer is this if we just delete this 1 because we don't need that. Okay, I'm going to delete these. All right, let's start with number 4. All right, so number 4. Okay, it's slightly different because there's a negative exponent, but it's the same exact process. So we bring down a negative 1 in front, rewrite the inside. The only difference here is that when we reduce the power by 1, it actually becomes a larger magnitude number, just negative, right? So it's negative 2. So just be careful of that. And then we multiply by the derivative of the inside, which is negative 2. All right. We consolidate this by multiplying negative 1 and negative 2, which is 2. Okay, so we end up with 2 times 1 minus 2x to the negative 2. Okay, and that's our answer. And then lastly, number 5. Okay, same deal. Bring down the 3, rewrite the inside. Reduce the power by 1, multiply by the derivative of the inside, which is 2x. Okay, and then I'll just make a little note about this one. You can rewrite this as x to the negative 2. Okay, so when you use the power rule on that, it's negative 2x to the negative 3rd. So this will be, the rest of this derivative here will be minus 2x to the negative 3rd. Okay, and then that is going to be your answer. All right, so hopefully that was helpful. Hopefully you get the pattern. If not, and you have any questions, feel free to email me or comment below. My email is mike@calculusboost.com. That is mike@calculusboost.com. Also, I'm going to be putting up some other videos, so check those out.